Moving along with some more calculus here with more differentiation. We're doing the product rule today and the quotient rule, and maybe some higher order derivatives if we have time. So the first one's called the product rule. And the product rule says that you take the derivative of, let me see, I'll read it here to you. The first function times the derivative of the second plus the second function times the derivative of the first. Let's do that on one. So the hardest part of the product rule is understanding what you're multiplying together. We are multiplying this chunk here times the second chunk here. These two chunks are multiplied together. Those expressions are products of each other. And I'm going to change it to an X instead of the letter S. The S just looks too much like the number 5, and we do bad things then. And then you're like, what is that? Is that a 5? Is that a what? I don't know. It's annoying. So anyway, here's one chunk, here's another chunk. I like to take, when I take the derivative, I just start with the first one. So the derivative of the first one, which is x, the square root of x, which is x to the 1/2. The derivative of that would be 1/2. Remember, you move it in front, 1/2 x, and then subtract 1 from that, and it makes negative 1/2. So I did the derivative of the first one now times the second one, which is x squared plus 8, plus then the derivative of the second one. So the derivative of the second one there, x squared plus 8, when you take the derivative of that, it's 2x, because 2, pull it in front, so 2x. So it's plus 2x, and then times the first one, which was the square root of x. So again, I took the square root of the first chunk, which was 1/2 x to the negative 1/2, times the second chunk. Then I took the derivative of the second chunk times the first chunk. And then we could clean it up a little bit. So on the top here, we have the number 1 over 2, and that's negative, so I'm going to float it down. So that makes it x to the 1/2. And on the top then, we're going to have x squared plus 8, because it's on the top, and then plus 2x square root of x. And we can just leave that alone. It's fine. You don't have to clean them up really too much. Well, you'll see when you have to, but yeah, we don't have to clean that one up. All right, so number 10, we got two chunks again. Here's a chunk, and here's another chunk. So again, I'm going to take the derivative of the first chunk, which is, again, x to the 1/2. So the derivative of that for g prime x is 1/2 x to the negative 1/2. 1/2 minus 1 is negative 1/2. And again, I pulled that in front, and then times the second chunk, and then plus then the derivative of the second chunk, which is cosine, times the first chunk, which was radical x. So again, we'll just, I don't know, you can clean it up a little bit. So that would make it 1 over 2 square root of x sine x, plus then square root of x cosine x. It just looks nicer to pull the square root in front of it. It's not a big deal. All right, then the quotient rule. I'll read it to you. So for the quotient rule, if f and g are differentiable at all values of x, which g of x is not equal to 0, then we can do the following. You could take the derivative of the numerator minus, well, you take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. All right, so what they're saying there is if you have two functions that are divided, you just start with the top. You take the derivative of the top times the denominator, and then minus the derivative of the denominator times the top. And then all that over the denominator squared. All right, so we're going to do that here on the next page. So on the next page, we have on here g of t equals 3t squared minus 1 over 2t plus 5. So when we do the derivative of it, g prime of t, when you do the derivative of it, again, you take the derivative of the top, and the derivative of 3t squared minus 1, 2 times 3 is 6t. The 1's just gone. And then times the denominator, which is 2t plus 5. and then minus. That's so sloppy. I think I can do a little bit better. There we go. All right, and then so I took the derivative of the top times the denominator. Now I'm going to do the derivative of the denominator. The derivative of this is just 2 times the top, and all over the denominator squared. So this one, you should do a little cleanup on it. So I'm going to distribute the 6t across it. So that would give me 6 times 2, 12t squared. And then 6t times 5 is 30t. Distribute the minus, so that makes minus 6t squared plus 2. And so on the x's, I have 12 minus 6, which is 6. And then plus 30t and plus 2 all over 3t squared minus 1 squared. We can just leave it like that. All right, then on the next one here, same idea. Again, you start with the top. The derivative of cosine is negative sine times the bottom chunk, which is t to the third, minus the derivative of the bottom, which is 3t squared, times the top, which is the cosine of t, all over the denominator squared. So I'm going to pull my letter in front. So that makes it negative t to the third sine t minus 3t squared cosine t all over t to the 6. When it's to the third to the second, it's a power to a power, and you multiply the powers. 3 times 2 is 6, because there's 2 t to the thirds. So t to the third and t to the third are 6 t's. All right, and then we can clean this up a little bit. We can factor 2 t's onto the top and take 2 t's onto the bottom. We have here 1, 2, 3 chunks. And so the quick way to think about this is you can take out or divide out of all of them on the top and the bottom. I'm going to do the same thing to the top and bottom. I'm going to factor out or divide out t squared from all of them. So I'm taking away 2 t's from here, so that makes it minus t. 2 t's from there just leaves minus 3. And 2 t's from that makes t to the fourth. So that is a nice answer for it. Negative t sine t minus 3 cosine t over t to the fourth. All right, and here's some more rules you can make flashcards over. The derivative of tangent is secant squared. The derivative of secant is secant tangent. And the derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. All right, so in our last lesson, which was lesson 11, we talked about the position function s of t. And if you take the first derivative of it, it gives you velocity. If you take the second derivative of it, you get acceleration. So doing a higher order derivative here, they've already taken the derivative of it, and now we have the velocity. So from s of t, they've taken the derivative, and v of t is 100t over 2t plus 15. The question is, where v is measured in feet per second, and t is measured in seconds, find the acceleration at 5 seconds. So if we want to find the acceleration, that means we need to take the derivative again, because right now we have the velocity. So if you do a derivative again, you've got the acceleration. So we need to find v prime of t. So it's a quotient. So again, you take the derivative of the top. The derivative of 100t is just 100 times the denominator minus the derivative of the denominator, which is 2, times the top, all over the denominator squared. So cleaning it up just a little bit, I'm going to distribute the 2 across, well, the 100 across it. So that makes 200t plus 1500, and then minus 2 across it, minus 200t. Look at that, it's gone. That's kind of fun. So that makes then 1500 over 2t plus 15 squared. All right, so then the last part here, they want to know what is it when the acceleration, what is the acceleration at 5 seconds? So when we did the derivative of it, it became, instead of v of t, v prime of t, it's the acceleration function now because you took the derivative of it. Up here, you've got v of v prime is equal to acceleration, or if you take the derivative twice of the position function, you get to acceleration. So anyway, they wanted to know what is the acceleration at 5 seconds. So the acceleration at 5, plug in the number 5. So 15 over 2 times 5 plus 15 squared should give us 2.5. I'm kind of scared. I think we should check that. So 2.4 feet per second squared. Let's check it. Let me get a calculator here. Ah, there it is. All right. So 1,500 divided by, let's see, 2 times 5 is 10 plus 5 is 15. So divided by 15 squared. Oh, no, that's not that answer. Let's see, 10 plus 15. Oh, that's 25, for Pete's sakes. 1,500 divided by 10 plus 15, 25 squared. There we go, 2.4. Score. All right, we're done with that one then. Okay, then we got one more question on the next page. No, we don't. We've got two. Okay, so on the next page, it says finding and evaluating a derivative. It says find f prime of x and f prime of c. So they want us to take the derivative and find the value at c, which is the slope. So if we find the value at c, that's the slope at 30 degrees for this function. All right, so let's go ahead and take the derivative. So f prime of x, it's a quotient. So again, take the derivative of the top first, which is cosine of x, times the denominator, then minus the derivative of the denominator, which is going to be 1, times the top, all over the denominator squared. So that gives us x cosine x minus the sine x over x squared. And they want to know what c of pi over 6 is. So f prime of pi over 6. So that'd be pi over 6 cosine pi over 6 minus the sine of pi over 6 over, x squared, which is pi over 6 squared. All right, so the cosine of 30 degrees, that's what that is. So it's the first one on your unit circle. The cosine of that is radical 3 over 2. So it's pi over 2 times radical 3 over 2. And then minus 1/2, again, the first one on the unit circle, over pi squared 36. So on the top here, I'll do it down here. So on the top here, we've got radical 3 pi over 4 minus 1/2, all that over pi squared 36. So I'm going to flip it over and make that 36 over pi squared on the top and the bottom. So it's gone on the bottom, and on the top, when you multiply across by it, one of the pi's are going to cancel out from the first one. I'll use a different color here. One of the pi's will cancel out right there, so that leaves a pi on the bottom. So we got 36 radical 3 over 4 pi, and then minus 36 over 2 pi squared. So that's the exact answer. And of course you could find like the rounded answer on it if you wanted to by plugging those numbers into your calculator. They didn't really say what they wanted the answer as, so I don't know. We could just leave it like that, I guess. All right, 76. It says, determine the points at which the graph of the function has a horizontal tangent. Oh, I do love this problem. If it's got a horizontal tangent means a horizontal line. So you got to think about what does that make the slope of it? The slope of a horizontal line is equal to 0. So where is the horizontal tangent? That's when the derivative of the function is equal to 0. Because remember, the derivative is all about the slope of it. So we need to find the slope of it. So I think I'm going to need another piece of paper here. It's getting messy. All right. Oh, I'll just flip this over. Okay. So doing this, we want to know when we take the derivative where it's equal to 0 at. So let's take the derivative. So it's a quotient. So I'm going to take the derivative of the top, which is 1, times the denominator minus the top times the derivative of the denominator, which would be 2x, and then all over the denominator squared. All right, so cleaning it up a little bit here. On the top, we have x squared minus 7, and then distributing that across there, you got 2x times x, so that's going to be minus 2x squared, and then 2x times the minus 4, and there's a minus out there, so that makes it plus 8x. So on the top, we have negative x squared plus 8x minus 7, all that over x squared minus 7 squared. We want to know when f prime of x, when is this equal to 0? Well, when it's equal to 0 is when the top is 0. If this is 0, the whole entire thing is 0. So we just need to worry about when the top is 0. When is negative x squared plus 8x minus 7 equal to 0? I'm going to multiply across by negative 1. So it cleans it up a little bit. And then that would factor. That actually factors, which is shocking. And x minus 7 and x minus 1. No, it doesn't factor. Does it? Yeah, it does. It factors into that. X minus 1. So the answers are 7 and 1. And they want to know at what points those were equal to, it said what points on the graph. So they want to know what points on the graph. When they say the graph, they mean the original graph, f of x. So this is when you need to be careful. So caution, don't plug those points back in the derivative to find the point. You would need to plug those points back into the original function. And the original function was x minus 4 over x squared minus 7. So at what points does it have a horizontal tangent? It has it at 7. So if x is equal to 7 and you plug in f of 7, you get 7 minus 4, 3 over on the bottom, 7 squared, 49 minus 7. All right, so 42, which is 1/14. So you get 7 comma 1/14. And then the other one is at 1. So if x is equal to 1, plug it in up here. So that would give you f of 1 is equal to negative 3. 1 minus 4 is negative 3 over 1 minus 7, which is negative 6 or a half. So the other point is at 1, 1/2. Let's look at the original graph to see whether or not we got our answers right. So the original graph, again, is x minus 4 in parentheses. Don't forget your parentheses. You want to divide the whole entire top by all of the denominator. So it was x squared minus 7 for the denominator. So there's the graph. Oh, let me clean my zoom up. I don't have it on standard. So zoom standard. So you can see it's horizontal a couple places there. So we set it 7. So let's check it. So second calculate number 6. Just type in the number 7. And we do get 0. That number is super small. 5.67 times 10 to the negative times e to the negative 10. That's just 0. The calculator can be so evil sometimes. You guys be careful. Use your common sense. And then trying it again at the other number, which was 1. You also get the derivative 0. Again, a super small number, which means 0. And then on the actual graph, we can check our values. Our value at 7 is a really small number, 0.0714. Let's see here. 1 divided by 14 is 0.0714. So anyway, we did them right. All right, I will see you for the next lesson.